Hey guys, so in this video we're going to be talking about vector operations. So there's two basic vector operations. There's scalar multiplication and vector addition. Scalar multiplication is pretty simple, right? So we're basically saying that we've got this scalar that we call k, all right? And we're going to multiply it to our vector. So over here in this diagram we see that if we take half of v, that our vector here becomes smaller. And that if we take 2, a scalar of 2, and we times that with our vector, that our vector becomes longer, right? So what happens when we multiply by a negative? When we multiply by a negative, look at the direction. It switched. It kept that same distance, but it switched directions. Well, what if I have a negative 3/2 as my scalar? No big deal. The negative means it's going to switch direction, so it's going to be going that other way than v. And because 3/2 is bigger than 1, it's, we multiply that by that, and it's longer, right? So multiplication is pretty simple. Okay, when it comes to adding vectors, what we're going to do is we're going to take, we take u plus v, right? So we're finding the sum here, the sum of u plus v. We're going to, here's our u, right? There's u. And here's v right here. Okay. So what we're going to do is we are essentially going to pretend like we could somehow cut out or move that vector beam. We're going to move it up so that the tail end of v comes all the way up here to u. So the whole thing's just going to lift up like it's magic, right? So that it attaches right here. Let's try that again real fast. There we go. All right, so that whole thing just lifted up, okay? Which we can see a little bit better over here in this diagram to the right. Here's u, right? And then v lifted up a lot nicer right there. And then the answer is going to be from the end of u, from the initial of u, all the way to the terminal of v, right? So there's our u plus v. This line right here, okay? And we call this our result, all right? The result of vector addition is the diagonal that we kind of created with that little parallelogram thing happening. You can see the parallelogram a lot easier over here on this diagram on the right, okay? But so that purple line is our resultant. So we see what that looks like visually, but how would we do that if we were given this in like component form, right? So let's look at that. Let's focus. Okay, so here we see the sum of u and v, right? Our sum is where we're taking these endpoints, well, our component form, our v1 and our v2s, right? Or our u1s and our u2s. And we're putting those together, right? So we're going to take our first components, so our u and our v, those first components, and we add them together. And then we take our second components and we add those together, right? And that's going to give us our u plus v. Now the scalar multiplication, it's a little bit easier to look at there. So that scalar multiplication is simply us taking the scalar k and timesing it by each of the u's, okay? But what are some other operations that we can do? Well, there's also the negative, right? Talked a little bit about that, and finding the difference, okay? So the negative, we're just taking -1 and timesing it by v, so by our vector. So that's pretty self-explanatory there. But the difference of u and v works pretty similar to that of what we were looking at for our addition. So we're going to come back over here to this in just a second, but I want to show you a visual first. So if we look here, okay, we've got u minus v, okay? So here's u right here, okay? And then here's vector v, right? So what we're going to do is we're going to kind of look at this like saying what we're really doing here is we are taking u and we're adding a negative v to that. So in order for that to all work out, then using the rule of negatives, what's going to end up happening is our scalar, that v scalar, it's going to end up kind of flipping directions, okay? So we're really looking at it in this direction now, okay? In that direction. And so now, just like we did with addition, we're going to take this tail end and we're going to move it up, right? Everything's just going to move up. And it's going to become right there, okay? And then what we're going to do is our resultant is going to be the distance from the initial of u to the terminal of v, which in this case is going to be this vector right here, this purple vector right here, okay? Now, we created this parallelogram looking thing, which means that technically we could look at it a different way as well, or not necessarily a different way, but know that this side over here is going to be the same, okay? So what does that look like algebraically? Well, let's come back up here. Okay, so looking at the differences, right, we see that all we're doing is taking our initial, our firsts, right, here, subtracting them, and then we're taking our second part of our component and we're subtracting it here, and that's going to give us our answer. And so here we see that it's possible to add, subtract, multiply, and divide vectors.